So in this tutorial we're going to look at transformations, and in particular the transformation that we call reflection. So what exactly is a reflection? What's going on? What kind of distortion or warping of the Euclidean plane produces this idea of a reflection? Okay. Well, what I'm going to do is just draw these together in my animation here, and you'll actually see what a reflection looks like. So we're going to use a swivel. You can think of reflection as a swivel, and the swivel goes like this. And what's actually happening here? Well, you've got two sides, and the sides are swapping over, basically. It looks like we're folding along this line here. But what's actually happening is all the coordinates on one side are going to the other, and all the coordinates on this side are going to the other as well. So we've got this swapping over. Now, if we draw onto that coordinate plane a point, a line, or a shape, then those are going to swap over as well. And that's why we get this mirror imaging. Okay, let's have a look at the opposite direction here. And so exactly the same, except we're folding in this direction instead. So we're going like this and then swapping over, so the right hand side has become the left and the left the right. Okay, now let's have a look a bit more carefully at what happens, and I don't think this is going to cause any difficulty, it's fairly obvious, but if we look at a square here, just fix our eyes on this square here, what's going to happen to that square, those 4 points? Well, as we run the animation, obviously that gets compressed, and it moves. It moves right up to the y coordinate at the y-axis, and then it comes out the other side and ends up here. So that's a reflection, and let's go ahead then and reflect some object. So it could be a point, it could be a line or a shape. I'm going to draw 3 points and join them together with 2 lines. So let's draw a line from here to here. And let's make a tick, so we're joining it up to 6, 4 up here. Okay, and now always a good idea to label anything we draw. So this is point A, this is point B, and this is point C. And let's write down the coordinates of A, B, and C. So A is 3, 2, so 3 along, 2 up. B is, what's B? 4, 1. C is at 6, 4. C is at 6, 4. Okay. Now, we're going to reflect in the x-axis, so along this axis here. So let's call this problem A. Reflection in the x-axis, and instead of the x-axis, I'm going to call this the line y equals 0, because all along the x-axis y equals 0, so we're going to call this y equals 0. Now when we're reflecting in y equals 0, the A point here, for example, is going to end up over here. What's going to happen to the x coordinate? Well, nothing. The x coordinate of the image over here, so the x coordinate of the image is going to be exactly the same as the x coordinate of the object, so we can write that like that. However, the y coordinate of the image is going to be the one that changes, so the y coordinate is, well, it's reflected in the x-axis, so it's going to be the negative of whatever the y coordinate is of the object. So the y coordinate of the image, we can say, is the negative, or it swaps it, it changes its sign, it changes the sign of the y coordinate of the object. And that's something that's pretty easy to remember and a useful formula, because when we've got this idea, we can then immediately, without using any geometric methods, go straight for A prime, B prime, and C prime. So A prime is going to be, so A prime down here, so this will be A prime. So A prime is going to be what? Well, the x coordinates are going to be the same. So 3 is going to stay 3. The y coordinate, though, changes its sign, so negative 2. B prime then must be 4, negative 1. C prime must be 6, negative 4. Okay, so let's mark those on here. So we've got 3, 2, we've already marked on. So 3, negative 2 is here. We've got 4, negative 1, so that's here. So that's, whoops, wrong colour. So B prime is here, and C prime is at 6, negative 4, so that's here. So lo and behold, our method works. Let's join it together, and you can see the mirror image. Okay, so problem B. Let's do a reflection now in, well, it's the y-axis, but we're going to call this x equals 0. So all along the y-axis, x equals 0. And the x-coordinate in this reflection is not going to be the same then, because we're swapping over to here. So the x-coordinate's the one that changes, but that swaps its sign. So the x-coordinate of the image is the negative x-coordinate of the object. The y-coordinate of the image, though, is going to, this time, stay the same. Okay? So we've got A prime prime is going to be, well, the x-coordinate of the image is going to change, so 3 becomes negative 3, but the y-coordinate remains the same. B prime prime, so 4 becomes negative 4, but the y-coordinate is unchanged. And C prime prime, negative 6 then, 4. Okay, so again, let's plot this on our graph. So we've got negative 3, 2. It's here, so that's A prime prime. Negative 4, 1, B prime prime. And negative 6, 4, C prime prime. Join them together, and we get our negative mirror image. Okay, so let's now think about what happens when we can't do this. We can't use these formula. Well, that's when the lines are not on the x-axis or the y-axis. They're not y equals 0 or x equals 0. They are y equals 1 or y equals 2 or x equals 3 or x equals minus 2. So in other words, they are parallel to the y-axis and the x-axis, but they're not actually on it. Means we can't use our coordinate system. So let's have a look at that. So let's erase these to start with. Okay. So let's get rid of those. Alright, so this time what I'm going to do then is I'm going to draw a line, let's say at x equals 1. So that will be here, going through 1 on the x-axis. Okay, let's label it. X equals 1. And let's start plotting our reflections. Well, this time, as I say, we can't use these, so we've got to simply calculate using geometric reasoning, really. So we know that A is going to go through here, just as before, but it's only got to go 2 to the line of reflection. Now, A prime prime, therefore, must be to the other side, so A prime prime must be here. Okay, so this is A prime prime. Sorry, let's just call it A prime. B is 3 to the line of reflection, so 3 the other side. B must be here. B prime. And C is 5 to the line of reflection, so 5 the other side. Careful to count that properly. And so C prime must be here. Okay, let's join those together. And we can see visually that we have got a mirror image, so we've correctly reflected ABC in x equals 1. Let's call that C reflection in x equals 1. finally, let's look, well, not quite finally, because what we're doing at the moment is 0 degrees reflections are when the line of reflection is parallel to the x-axis. 90 degrees is when we've turned that line, then 90 degrees. 90 degrees means vertical. We're finally going to end up with 45-degree line of reflection. But let's just complete this little part. So we'll do a reflection now at 90 degrees. So in the, not the y-axis, but let's say y equals 2. Y equals 2, problem D. All right. So we need to draw our line y equals 2. So there's 2. So we draw our line across like this. And let's label it. So y equals 2. And now let's take ABC and work out where the coordinates are for A prime prime, B prime prime, and C prime prime. Well, if we start with A, we've got A, the point A is actually on the line of reflection. So what's the distance to the line of reflection? Well, it must be 0. In other words, if the distance to the line of reflection of A is 0, then A prime prime, the distance to A prime prime from the line of reflection must be also 0. So it must be also 0, so it must be there. So a little bit of a tricky one, this one, because the line of reflection is going through the object, basically. Okay, B, again, we need to be a little bit careful. We have to go to the line of reflection, 1, and then the distance, the other side must be the same, so B prime prime must be there. And C prime prime goes in the other direction, so to the line of reflection, it's got 2 units to the line of reflection, so the distance, the other side must be the same, so C prime prime must be there. And we can join those together, and let's see if that looks correct. Okay, so it looks pretty good. I'm quite happy with that. All right, finally, let's first of all erase this part here and here. Okay, finally, let's get rid of this and this. Okay, let's draw our 45-degree line of reflection then. And the simplest 45-degree line of reflection is going to go through the origin. Okay, so it's actually going to go from -6 to 6, 6. So now what would we call that line? Well, if the y value equals the x value, so -6 equals -6, 6 equals -6, and so on, 0 equals 0 at the origin, then this is the line y equals x. So let's draw that in. Okay. So from -6 to 6, 6, going through the origin like that. Okay. And this is the line y equals x. So problem, we haven't got much room now. Let's put it over here. Is there going to be room? Yeah, let's put it down here. Okay. Problem E then is a reflection in y equals x. Okay. So to reflect in y equals x, we can use the method we have here. In fact, if you think about it, A is going to end up here, so that would be A prime. And what's happened is that the x coordinate, which is 3, has become the y coordinate here, okay, which is 3. And the y coordinate here, which is 2, has become the x coordinate, which is 2. So the rule here is very simple. A reflection in y equals x, the x coordinate of the image is the y coordinate of the object, whereas the y coordinate of the image is the x coordinate of the object. So they swap around. That means that A prime is going to be just swapped around like this. So 3, 2 was A, so 2, 3 is going to be A prime. B prime is going to be 1, 4. And C prime, well, that's going to be 4, 6. Okay, so 2, 3 is here, 1, 4 is here, and 4, 6 goes up here. Let's just draw those in then. Okay, and label them correctly. A prime, B prime, and C prime. Like that. Now finally, before we have a look at something a bit more advanced in part 2, there are problems in the GCSE exam. Very commonly, you're given a problem where you're not given the line of reflection, but you have to find it. So let's say you're not given y equals x, for example. So let's just delete that one. Okay. Okay, so you're not given the line of reflection. And in fact, let's just join these up so we can see them as triangles. I think that will make things a bit clearer. Okay. So let's join A prime to C prime and A to C. So now we've got two triangles. Two isosceles triangles, in fact, as far as I can see. Yes, two isosceles triangles. So we've got to find the line of reflection, which we know, of course, is y equals x. But what if we didn't know that? How would we find it? Well, there's two ways of doing it, really. You could join A to A prime and C to C prime, just two will do, and bisect those lines. But I'm going to suggest another method, which is what if we use the idea of vectors. So instead of going directly across from A to A prime, we just, or let's go in the opposite direction, A prime to A. Then how do we get from A prime to A? We would go along, let's use brown, we would go along in the positive direction, 1, and down in the positive direction, 1. And that gives us a point here, which is also bisecting. It's also going to lie on the, it's not bisecting, I guess, but it's also going to lie on the line of reflection. And it just makes life a little bit easier, I think, when you've got lines on the vertices of the square grid. Okay, so we're now going to go from C prime prime along 2 to get above the C, and down 2 to complete those two vectors. So you can think of these as vectors in this direction. Okay, so now all we need to do is join these 2 points together. They must both be on the line of reflection. So if we draw a line from here to here and just extend it all the way down, then we have identified geometrically the line of reflection. Now we know it's y equals x, but how would we find that if we didn't know what that line was, if we couldn't just simply recognize it? Well, what we need to do is think of it as a formula. So y, any line on a grid, is y has the formula y equals something x, so the gradient times x, so we'll leave that blank for the moment, plus some sort of, let's call it m, so the gradient m, plus some sort of constant, and the constant is going to give us the y-intercept. Now the y-intercept in this case is 0, so c is going to cancel. So the y-intercept is 0, and the gradient m, well, that's going to be the difference, it's going to be the rise over the run. So the difference in the y values of any 2 points over the divided by the difference in the x values. Now if you're not sure what I'm talking about here, rise over run, you need to go back and have a look at the graphing videos that we've done on this. But as long as you understand this, rise over run should be fairly familiar. So let's take these 2 points here. Okay. So at this point we have to rise up 3, and we run along 3, so difference in the y, 6 minus 3 gives us 3, and we run along 3, so difference in the x is 6 minus 3 as well, so also 3. So 3 divided by 3 must be the gradient, and c is the y-intercept, which is 0. So we've now got y equals 3/3 x, in other words, y equals 1x, or just x. So we found our line of reflection. So this is the line of reflection if that wasn't given to us, and instead we were given an object and the image. Okay. So lastly, again, hopefully you've had a look at the rotation video. If not, go back to that, because I think otherwise this might be a little bit confusing for you. But if you have had a look at the rotation tutorial, then you might be intrigued to know what the matrix is for reflection. Well, let's have a look at a couple of those reflections that we were looking at. So let's start with reflection in the y-axis. So y-axis, in other words, x equals 0. Now the reflection in the y-axis is vertical, and so we say that's at 90 degrees, so therefore 90 degrees. We'll also have a look at reflection in y equals x, so the diagonal y equals x, therefore reflection at 45 degrees, although remember both of these go through the origin, so this 45 degree has to go through the origin, otherwise we can't use the method we're going to use now. Okay, so what we're going to do is try and combine all three of those formula: reflection in the x-axis, reflection in the y, reflection in y equals x, and in fact any angle, by referring to trigonometry. So let's use a slightly different colour here. Okay, so first of all, let's have a look at reflection in the y-axis. Well, with reflection in the y-axis, or in fact any of these reflections, the x of the image follows this formula here. So let's have a look at that now. So the x of the image can be found for any type of reflection by calculating the cosine of double the angle. So the angle here is 90, and that will give you, multiplied by the whatever the coordinate of the x coordinate of the object is, that will give you the x coordinate of the image if you're also adding the sine of double, in this case 90 degrees, the angle of the line of reflection, that times the y coordinate of the image. So I know this sounds a little bit convoluted at the moment, there's quite a lot there to get your head around, but we're going to give an example. So let's go ahead and look at reflection in the y-axis. In fact, let's do reflection in the y and reflection in y equals x. So reflection in the y first. So the x coordinate of the image then is going to be the cosine of 2 times 90, so the cosine of 180. And that's multiplying by the x coordinate of the object that you're given. Okay. To that we need to add the sine of double 90, so the sine of 180, and that's multiplying the y coordinate of the object. Okay. Now, what does that all boil down to? The x coordinate of the image then equals, well, what's the cosine of 180? Cosine of 180, you can check on your calculator, it's the same as cosine of 0. So it's -1. So it's the cosine of 0 is 1, cosine of 180 then is -1. So we've got -1 times the x coordinate of the object. So it's negative x coordinate of the object plus the sine of 180. Well, the sine of 180 is like the sine of 0, if you like, the negative sign of 0, which is also 0. So sine of 180, if you check on your calculator, is 0. So we don't need to add this component. 0 times the y coordinate of the object, so no y coordinate of the object. So we're done. The x coordinate of the image is negative the x coordinate of the object. Let's just make that a bit clearer. Okay. So, what about reflection in y equals x? Well, the x coordinate of the image in this case, again, follows this formula. So we've got the cosine of, and the only thing that changes is the angle. Well, we've got 45 degrees now. So the cosine of double 45 degrees, 2 times 45 degrees, is the cosine of 90 degrees times the x coordinate of the object, plus the sine of 90 degrees, so double 45, times the y coordinate of the object. Now, again, this is going to cancel out because the cosine of 90 degrees is 0. So we don't have the x coordinate of the object. The x coordinate of the image is simply sine of 90 degrees times the y coordinate of the object. Well, sine of 90 degrees is 1, so we just write down y coordinate of the object. And we have then something that we had before. X coordinate of the image is, in reflection in the y-axis, changes its sign. The x coordinate of the image in reflection in the diagonal y equals x, the x coordinate of the image becomes the y coordinate of the object. So the formula works in these cases, but the nice thing about the formula is it works in all instances, so for whatever angle the line of reflection happens to be at. Okay, good. Now let's work on the y coordinate. So let's use a slightly different colour. And let's use a green. Okay, so the y coordinate of the image follows this formula here. So this completes the matrix. You can think of it as a matrix, these four coefficients here, if you like. So now the y coordinate of the image is sine of double 90, so in this case 2 times 90, so 180, times the x coordinate of the object, plus the negative cosine. So they're swapped around. You remember in the previous formula we had the only negative was on the sine here. Now in this version for a reflection the only negative is in the bottom right hand corner of the matrix here. So we've got plus negative cosine of 180 times the y coordinate of the image of the object. Okay, like that. So now all we need to do is work this out. Well, sine of 180 is 0, so we don't have the x coordinate of the object. Negative cosine of 180, well, cosine of 180, as we said, is negative 1. So negative cosine of 180 is negative 1. In other words, positive 1. So positive 1 times the y coordinate of the object is just 1 times the y coordinate of the object. In other words, just y coordinate of the object. Okay, and so that completes reflection in the y-axis. The x coordinate of the image becomes negative. The y coordinate of the image just stays the same. So what happens in the other? Oh, let's just change the colour slightly just in case they get confused. So reflection in y equals x, the 45-degree angle. What should happen there is the y coordinate of the image becomes the x coordinate of the object. Okay, let's see if this works. So y coordinate of the image is the sine of 2 times 45, so sine of 90 times the x coordinate of the object, plus the negative cosine of 2 times 45, 90 times the y coordinate of the object. Therefore, the y coordinate of the image is, well, sine of 90 is 1, so just becomes the x coordinate of the object, and cosine of 90 is 0. So all of this gets eliminated. So we have got what we were expecting. The x coordinate of the image in a reflection in y equals x, the x coordinate of the image is going to be the y coordinate of the object, the y coordinate of the image is the x coordinate of the object. So there we are.